Hello, I welcome you all to your own channel MSK Learnium. In this video, we are going to discuss about the gyroscopic couple. So let's say that you have one disc is there. Okay, the disc is rotating on an axis OX with an angular velocities of omega, right? And it is rotating in anti-clockwise direction. So I have drawn one axis OX, and on that axis we are using one disc. Okay, so this disc is rotating with an angular velocities of omega, right? Now after certain time t, that the disc is shifted to certain distance, right, and it reaches to the new position, that is we call it as a x dash, right? So this is the new position of the disc with an angular velocities of delta theta, you can say, right? So this much of displacement is covered by the disc, that is delta theta. Now, so this is the vertical axis, we can say OY is the vertical axis, and you have a z axis, that is the this will be your, let's say this is your zz axis, right? So this is your z axis. Now what you need to do, that this will be your like this. Okay, so we are drawing one this is the z axis and this is the z dash, right? This is z dash. So we are drawing one plane, that is the XOZ. XOZ is nothing but this will be the like this. This is the XOZ plane. One more plane we have to draw, that is YOZ. So for YOZ you have like this, and this will be like this, right? So I'll show you with the dark color, that is this is your YOZ plane, okay, and this is the Z axis, right? And this will be your XOZ plane, right? This is your XOZ plane. Okay, now so the disc is rotating on an OX axis with an angular velocities of omega anti-clockwise. After a certain time, let's say that after delta t, the disc is reaches to the new position OX dash, right, of with angular displacement of delta theta. So if you look at this, that is what this XOZ is known as the plane of horizontal plane, right? And this is YOZ is the vertical plane. So here you can say the YOZ is the plane of spinning, and the XOZ is known as the plane of precision, right? OY is the axis of a spin, and the OX is the OY is the axis of precision, and OX is the axis of spin. So now you can write that OXOZ is a plane of precision, right? Plane of precision is nothing but the precision axis of precision, you know, with the axis which is perpendicular to the axis of spin, right? And YOZ is a plane of spinning, right? Is plane of spinning. And the OY is the axis of precision, right? Axis of precision. And OX is the axis of spin, right? Is the axis of spin. Now what we have to do, that we consider that one disc is there which is rotating with an angular velocities of omega in anti-clockwise direction. Now we need to find out the angular momentum of this disc, right? So for that, what we will do, that we have to consider that, let's say that I is the moment of inertia, mass moment of inertia of this disc about OX, and omega is the angular velocities. So here you can say let omega is the angular velocity of disc, right? Angular velocities of disc. And I is the mass moment of inertia of the disc about OX, right? Then we can find the angular momentum of the disc. We can find angular momentum of disc, right? So angular momentum of disc is what? That angular momentum of the disc is nothing but I into omega, mass moment of inertia into angular velocities. Similarly, you can find out the rate of change of angular momentum, right? First we have to find out the change of angular momentum. So you can say that change in angular momentum, change in angular momentum, right? Change in angular momentum, that is what? Change in angular momentum, we can say Ox dash, right, is equal to, the change in angular momentum is nothing but the Ox dash minus Ox. If you look at here, that is, the body was initially, it was spinning on the axis Ox, and after certain displacement it reaches to the Ox dash. So this much of momentum has changed, right? So and change in angular momentum is what? Ox dash final minus initial. So that what we are doing. So here you can write that is equal to Ox, that is equal to xx dash, right? This is the xx dash. So then we can say that xx dash is equal to what? That is Ox delta theta, right? So this is the angular momentum, change in angular momentum, right? And further you can write that is equal to I omega delta theta. So this is the change in angular momentum we got. Now what we need to do, we have to find out the rate of change of angular momentum, right? So you can say that rate of change of angular momentum, here rate of change of angular momentum, right? Rate of change of angular momentum, right? So rate of change of angular momentum is what? Means whatever the angular momentum we got, we just differentiate with respect to the time. So it is nothing but I omega delta theta by del t, right? By delta t. This is the rate of change of angular momentum. Also, you know, the rate of change of angular momentum will result by the application of a couple, right? So you can say, therefore, the couple applied to the disc is equal to what? Causing precision, right? That is why, because the rate of change of angular momentum is a result of an couple, right? So that's why we can say the couple applied to the disc causing precision. Because of that couple only the disc is precision right now. So C is equal to, that couple is C is equal to limit from delta t tends to 0. This is what? I omega, right, delta theta by delta t. As we have substituted the limit, so this will become I omega d theta by dt. If you see, d theta by dt is nothing but the rate of change of angular displacement, right? And the angular displacement, rate of change of angular displacement is nothing but the angular velocities. So this angular velocities is where? This angular velocity is in the angular in case of the precision, right? So you can say C is equal to I omega p. This is your gyroscopic couple, right? In case of the precision, when the disc or body is in precision right now, so the gyroscopic couple will get, that is I omega p, where I is nothing but the mass moment of inertia, omega is the angular velocities, and omega p is the angular velocities of precision. Now as you have to see the gyroscopic effect, right, and the gyroscopic couple, whenever you have to find out the gyroscopic couple, means magnitude, then you have to use this equation, right? So the gyroscopic effect we have to discuss in case of the aeroplane, naval ship, right, as well as in four-wheeler and two-wheelers right now. So that effect we have to see by means the effect will be depend on that rotation of the body, right, and in which direction it is taking turn. Means rotation of the body means if you are talking about the aeroplane, right, so in case of the aeroplane, the rotor is rotating in clockwise direction, anti-clockwise direction, or the plane is taking left turn or right turn, or all those things right now. So first of all, the gyroscopic couple you can get by using this, and the effect you have to see. Then the gyroscope is a device, right, or you can say that it is an instrument right now, so which is used in gyroscopic principle. So you can make a point that the gyroscopic principle is used in an instrument in an instrument or toy, right? Then that is known as the gyroscopic, right? Is known as gyroscope. Okay, is known as the gyroscope. The gyroscope are installed. So we are using the gyroscope in aeroplane, naval ship, right, and monorail car also, right now. So the gyroscope instrument which is used in naval ship is used to minimize the effect of rolling and pitching, right, in wave. So you can say the gyroscope used, that is installed, this is the application, you can say, installed in naval ship. Here you can write in naval ship, right, in order to minimize the effect of rolling when the ship is rolled and pitching, right, rolling and pitching of wave, right, of wave. Is it or not? So now the gyroscope we have to install in an naval ship, right, to minimize the effect of rolling and pitching when it is off wave, right now. So these are the application of the gyroscopic couple. So whatever the things we have discussed, that gyroscopic couple formula we derive, right, that C is equal to I omega omega P. How we can implement these type of formula in a numerical problem, we will see with some simple example, right. So the problem is on the screen. So the problem is on the screen. Please write down that a uniform disc of diameter 300 mm and mass 5 kg is mounted on one end of an arm of length 600 mm. The other end of the arm is free to rotate in a universal bearing if the disc rotate about the arm with a speed of 300 rpm clockwise looking from the front. With what speed will it precess about the vertical axis? So you have a question is given that a disc is there whose diameter is 300 mm and mass is 5 kg, mounted on one end of an arm of length 600 mm. The other end of the arm is free to rotate, right, in a universal bearing if the disc rotates about the arm with a speed of 300 rpm clockwise looking from the front. With what speed will it precess about the vertical axis? So you have a disc is there whose speed is given. Speed is what? That, sorry, diameter is given. That given data, you have a given data, right, that is D is equal to 300 mm. Okay, it means 0.3 meter, and the mass is given, M is equal to 5 kg of the disc, and the length of the arm by which the disc is connected is 600 mm, right. So it is nothing but the 0.6 meter, right. The other end of the arm is free to rotate in universal bearing if the disc rotates about the arm with a speed of 300. That is the speed of the disc is given about the arm with a speed of, yes, so N is equal to 300 revolution per minute clockwise looking from the front. With what speed will it precess about the vertical axis? Means speed they are asking. Which speed they are asking? Precision speed they are asking. Means with what speed? With what speed will it precess? Means the angular velocities of precision you have to calculate, right? So omega P is equal to what? Okay, now, so first of all, what you need to do, you have to find out the gyroscopic couple, right? So couple is what? Couple is nothing but the force into distance, right? Force into distance means what? The force on that disc into length of the arm, right? So first you can find that C is equal to mass into gravity into length, right? So mass is what? Mass is nothing but the 5, and the G is 9.81 into length is 0.6. So you can get, that is 5 into 9.81 into 0.6, sorry, 5 into 9.81 into 0.6. So you got some value, that is 29.43 Newton meter, right? You know the gyro means the disc is there, right? And the moment of inertia, mass moment of inertia of a disc about a rotating axis is nothing but you have a mr square by 2, right? So mass moment of inertia of the disc, you can say mass moment of inertia of a disc, right? Disc is nothing but a circular plate. So it is what? I is equal to mr square by 2. M is what? 5. R is what? R is nothing but the 0. D is 0.3, so it will be 0.15, right? 0.15 whole square by 2. We'll get some value, that is 5 into 0.15 whole square by 2 mr square by 2. 0.05625, 0.05625 kilogram meter square, right? We got this mass moment of inertia, we got 0.0562 kilogram meter square, right? Kilogram meter square. Then you have a C is equal to what? That C is equal to, you know, gyroscopic couple, C is equal to I omega omega P. So omega P is nothing but that is C by I omega, right? So C you have, C is equal to, you calculated, which is 29.43, right, by this. I is equal to what? 0.05625, and omega is nothing but the 2 pi n by 60 you can calculate, right? So omega, you can see that omega is the 2 into pi into n is 300 by 60. So 31.41. So this is your 31.41, right? So by using this you can get the answer that 29.43 by 0.05625 into 31.43. So that is our angular velocities of precision is nothing but 16.64. So this is 16.64 radian per second, right? So this is how we will calculate the angular velocities of precision of a body with such problem, right? So these are the things. In next video we are going to discuss the effect of gyroscopic couple in case of the four-wheeler, aeroplane and a naval ship. So please do like, subscribe and comment and share this channel. Thank you.